nitrogen and potassium as macro elements, and I'll write these fairly macronutrients. And I said those are the two big ones we have in California deficient, and then we have zinc and boron as micronutrients, which, remember, are just as essential to reproduction of the plant, or as considered essential elements, as macronutrients. And perhaps this might be a time to mention a definition of what is an essential element. I didn't do this to the Monday class, but an essential element in the idea of plant nutrition is one that is required for the complete reproduction of the plant. For the complete reproduction of the plant. You may only want the root, you may only want the top. So maybe the micronutrient, or the nutrient, the element involved, is not essential from your standpoint. But from the definition of essential nutrients, it means to take it from the parent through the child to the parent to the next child, if you want to look at it in terms of human analogy. So that a micronutrient is just as important as a macronutrient if it's required in that sense. One other thing that I did not mention in the other class is that a micronutrient has an odd position in that it only requires an extremely small amount of it to take care of this essentiality. But more often than it is the case with the macronutrients, a little bit of excess can be injurious rather than helpful. And let me give you the human analogy, in that some umpteen years ago they found out that iodine was required in extremely minute amounts to prevent goiter of the human being, the big swellings and so forth on the throat. So that's why you have iodized salt today. In part, it's also why you have fluoridated drinking water in some enlightened communities, Davis not being one of them. We have people in this town who are afraid of fluoride. But anyway, some of the more enlightened communities put fluoride in their water to prevent teeth decay. So these are micronutrients, which I should not have brought in the fluoride. That just happened to be a passing thought, so I could throw a dig at some people. But iodine fits into what I'm talking about, that you need a trace of iodine to prevent goiter, and that's why you have iodized salt. But you can easily commit suicide by drinking a little bottle of iodine, because it's quite a poison if you take it in excessive amounts. Now keep this in mind as we go through zinc, or particularly boron, that you need a small amount to take care of the deficiency, but you can very easily throw it into toxicity by just overdoing the dose. Okay, now we get back to these nutrients. We're going to talk about numerous ones this afternoon, but just once again for your records, and those of you who are really seriously interested in growing grapes in California, those are the only four you have to worry about. And we've already discussed nitrogen in great detail, except for the comment I made you this morning that I wish I'd thought to throw in a comment that another bad fact about cover crop is that it increases your susceptibility to frost injury. All right, this afternoon we're going to discuss these others. And remember, my format here was to work with the identification or diagnosis or identification of the deficiency, and then to worry about where it occurred, which I would refer to as where its incidence, the incidence of the deficiency. And we're talking about of the deficiency now. Well, we'll talk about toxicity too, so let's leave that word, the incidence, and then the correction or treatment for it. Correction or treatment. And the one we're going to start out with this afternoon, of course, is potassium. And whereas I made a big point when we were talking about nitrogen with regard to grapes, that there's a big zone of so-called hidden hunger of the grape for nitrogen. Hidden hunger, a term used most specifically among mineral nutrition people. Hidden hunger meaning that it shows no visual symptoms of deficiency, but you are suffering a crop loss. And that's why we dwelt so strongly on tissue analysis with regard to nitrogen, because it has a wide zone between sufficiency level, sufficiency, to a deficiency level. There's a big zone here in which we would call it hidden hunger, or HH is how I use it here, of hidden hunger. So you have to figure out some sort of tissue analysis or some sort of diagnostic technique to make up for the lack of visual symptoms. But with regard to potassium, we don't have this problem. We don't have this problem, that was with regard to nitrogen, but with regard to potassium, we don't have this problem of hidden hunger because unless I'm mistaken or unless something has come out in the last few years, I don't know of any really well-documented publication on potassium fertilizer research on grapes in which they can really prove that they got a response to potash applications unless they had visible symptoms of deficiency, which translated means that there is an extremely narrow zone then of hidden hunger in potassium. For example, suppose at a given time during the year you take a petiole sample and you run it for potassium and get 0.60% K and no symptoms. But in a vineyard nearby, you might run a sample where they had visible symptoms and get 0.50% K. Well, this zone then is so close, 0.1%, that this can cover sampling error and all sorts of varietal errors and so forth. So tissue sampling in this case is not really worth a great deal. I mention every now and then to you about Dr. Shawless, who does the nutrition work and every other kind of work at Geneva, New York, the field station for Cornell University. And he and I have been carrying on a friendly fight for about 15 years about when to take petiole samples to determine if you need potassium. I tell him you don't really need to take petiole samples at all. All you need to do is to learn to recognize the symptoms. But if you're going to take samples in California, for example, for potassium deficiency, you ought to take them at bloom time or early in the season. And I'll just tell you now, what I'll tell you later on, that we, in California, we advocate taking samples at that same position opposite the cluster, like we did for nitrogen, at bloom time, and then 1 month later, resampling the vineyards which might be under suspicion of being low. And under this situation, what I'm getting at is that sometimes you can have a situation where you have percent K, and this being the season as it goes on, and this can be bloom time, and this can be 30 days later, plus 30 days, and you can have a situation where maybe potassium here is 1.0 on one variety selection, and it stays about like that as you go on into the season. You can have another one that's very close to 1.0, and it'll drop down like this. And this, the fact that both of them are about 1.0 may be due to the fact that they had a chance during the late fall or something to collect potassium slowly in the root zone, or a situation where potassium is slowly available, and therefore you can collect it until there's a great sudden demand on it. So then when you take the sample 30 days later, you might get a difference between these two. But Shawless argues very strongly that we ought to go out here to harvest time and take the sample, because he says you get such a high correlation between low potassium and visual symptoms. Well, if you get a absolute high correlation between visual symptoms and tissue analysis, why bother with tissue analysis? As I tell him, and then that sort of rocks him back a little bit. You see, if you're going to use tissue analysis as an indicator of potassium deficiency, and it correlates 1-to-1 with visual symptoms, why spend the money for tissue analysis? Why not just look at visual symptoms? And he thinks this is a wonderful time to sample because he gets high correlation. I said, well, Christ, anybody will get high correlation if you go take a deficient vine every time and sample it. But he and I say it's a friendly argument, but he is still stubborn on this idea that that's the time to sample. Now, the other reason why I don't like to sample at that time of year, and I've got this lecture sort of reversed for compared to the other class, is that two things depress potassium when you get out close to harvest: drought and heavy crop. And he doesn't worry about droughts because they get rain all during the summer and so on back east in New York State. But we often in the coastal counties with non-irrigated vineyards, we have extreme drought conditions in the fall, and potassium drops off very rapidly. So that if you want to correlate and really find out whether or not you have low potassium, why not take it back at bloom time when you still have plenty of soil moisture and you haven't had the effect of the heavy crop load to depress the potassium. But there must be something wrong, because as simple as that seems, Dr. Shawless has not accepted it for 15 years, so I don't know what's wrong. Okay, now we're talking about this business, so going back to my procedure, diagnosis or identification, and I got off the subject here, the idea that you have a very extremely narrow and so narrow range that it's not practical to consider tissue analysis as the important way to determine potassium deficiency. And therefore, the most important way to diagnose potassium deficiency is to recognize the symptoms. So let's look at the symptoms, because this is the most important thing about potassium deficiency. You have to lift it by hand. It won't turn up that way. Just you loosen it and then raise it. Yeah. But you're going to have to raise it. Let's put it up fairly high. Okay. Raise it. Well, now that's too high. You're going to have some of them off the scale. Can't you get it down here? What's so hard about that? That thing, that red button, loosens the screw. All you got to do is loosen that red button and set it where you want it and then tighten it. Yeah, I know. Okay. Okay, now we're in good shape. Well, these are the very first symptoms you get of potassium deficiency. This variety happens to be Carignan, and this is potassium deficiency early in the spring. Now, let's open the blinds, if we will, there. Margaret, open them, because I think they can see all right, because they have to take notes. They want to take some notes. By the way, most of the basic material I'm going to tell you this afternoon is in the textbook, if you'll read that chapter. What I want you to do this afternoon is concentrate on recognizing the symptoms, because you're going to get these slides on the final exam. So you better learn to know them, and or something just like it. And now potassium deficiency normally doesn't show up unless it's in extreme situations. It doesn't occur until about sometime after bloom time, unless it's severe. Of course, the more severe, the earlier it shows. And it begins to show with this pale golden or chlorosis color around the edges of the leaves that you see in all of these. This happens to be Carignan from Lodi, and a early stage of potassium deficiency. This gloss that you see is not poor photography. It's a waxiness that appears on the leaves. So you get this fading and underlying gradual fading of the color from the margins inward between the veins, and a bronzing or yellowing depending on, and then finally a reddening depending on whether it's a red or white variety. And then you get this sort of a red, this waxiness that appears on the surface of the leaves. And I say this is not poor photography, that's the way it appears with this. It looks like somebody melted wax real hot and then poured a real thin splat of a candle on top of it without burning the leaf. That's what it appears in many situations. Okay, that's the very first type of symptoms you see. Let's go on to the next slide, please. Yes?
Is it possible to mistake these deficiencies for various virus disease?
Yes, there is, but we'll discuss viruses and their relationship later, and I'll discuss a comment or two here in a moment about this. But for nutrition purposes, right now, I'll get to your point in a moment. Now, one of the things about potassium, which is rather unique, is that many nutrition deficiencies occur on the older leaves first, or on the terminal leaves first. But so far as I know, potassium's the only one that when you're on the ragged edge of the deficiency, it occurs on the mid-shoot leaves. And this is a shoot out of a greenhouse with stand culture work, and you can see the bottom leaves that look perfectly healthy. The young ones out here, that probably is photography there, but this is nice, succulent growing there, but you begin to get this chlorosis around the edges of the leaves that you get in this area here, in the mid-shoot portion on an incipient or a borderline case of potassium deficiency. Next slide. Let's see if we, Margaret, pull that one behind you, will you? Pull the drape behind you because it's almost too light. Yeah, that's fine. Okay, thank you. Now, one of the, we're going to show some varietal differences, but since Thompson seedless is our most important variety, it's interesting to show potassium deficiency on it. And one of the unique things about Thompson seedless is this extreme rolling of what we refer to as the lobes of the leaves. And you see what goes on here. The bottom leaves are still healthy, and the ones up above my hand here are okay, but you still see the waxiness on these leaves that are in this zone, and you see this extreme rolling. Now you can get this extreme rolling with just plain excessively high nitrogen. But if you get the rolling and you unroll them and you see some chlorosis along those edges, then you can suspect potassium deficiency. So it's the rolling of the lobes of Thompson seedless accompanied by this marginal chlorosis gradually going in between the veins. Next slide. And here's a lineup of Thompson seedless late in the season when the vigorous growth is over. This is a supposedly healthy leaf. Here's varying stages from mild to extreme potassium deficiency, and you see again the waxiness appearing on the leaves, and then this chlorosis, which I don't like this leaf at all, but this wasn't my slide. But you see the edges are beginning to burn and to turn and roll. And they may roll up or down. And keep this in mind that the edges of the leaves will roll. And then you get this extreme type of situation here, but still getting the waxy surface on the leaf.
So that's a purely Thompson seedless characteristic, the rolling?
Most of them will roll, most varieties will roll this type of roll, like this, a little bit of roll at the edge, but that extreme rolling of the lobes is characteristic of Thompson, yes. Okay, next slide. And here's what you were just getting at. Here's some samples that I took from Thompson seedless showing potassium deficiency in the field with the chlorosis, the edge burn, which all varieties show, and this leaf, this rolling of the lobes that you can see here under field conditions, also with those waxy spots. And by the way, these leaves are thinner than normal. They're a thin type of leaf, so that you get here a very slight trace and various stages here of potassium deficiency on Thompson. Remember, the reason I'm showing you these, once again, is that I don't know of any situation in which we've gotten a real, well-documented, authentic report of potassium response or response to potassium fertilizer unless you have the symptoms. Okay, next slide. And here shows the effect of potassium deficiency on Thompson seedless fruit. And here you can see the extreme potassium deficiency. These I took while they were harvesting the fruit. And you see here's a cluster of grapes, and the bottom half of it is all dried up. A cluster of fruit with the bottom half all dried. It's dried because it doesn't have any sugar in it. It's nothing but dry skin, really, with some water in it. And you might say it's just an extreme example of overcropping, and basically it is, because you had such poor leaf surface that you did not develop sufficient sugar to develop the fruit properly. So where you have potassium deficiency high enough to affect a significant proportion of the green foliage, then you can get effects on fruit quality. But what a lot of people like to argue, and fertilizer salesmen in particular like to argue, that you're going to get increases in fruit quality with potassium application, period. And you don't get it unless the deficiency is severe enough to appreciably affect your green, what's this? That's your factory. Unless it's appreciable enough to affect your sugar producing factory. Now these are referred to in the industry as waterberries. And we have two types of waterberries in the industry. We have this type, which is related to potassium deficiency. That's waterberry. We also have another type of waterberry in which we have only on a normal looking cluster. Let's assume this is a cluster of grapes here, where you may have a berry here, a berry here, a berry here that dries up or is sour. If you ever really stop to think about it, when you're eating raisins, every now and then you eat a raisin that tastes sour. Try that the next time you eat some of these $1-a-pound raisins. And that raisin that tastes sour is a waterberry raisin that occurred in a normal type cluster like this, usually. And we still do not have the answer to that. There's a talk going on right this minute over in me room of the Memorial Union, in which the guy is Dr. Hewitt from Kearney Station is arguing that it's caused by a calcium deficiency. I would like to be there hearing it because I don't believe it. That's for the TV too. That'll be on record. Because he's going to argue that the waterberry, this individual berry business, is caused by calcium deficiency. And I would like to hear the talk because I'd like to ask him how, in a state like California where Lyme-induced chlorosis on all crops is caused by excessive lime, how can you have calcium deficiency? But he's given some argument as to prove this afternoon. And I'll get the notes on it, maybe give you a brief on it next week. But anyway, get away from that. This type of waterberry, in which the bottom portion, a third or half or more of the cluster, is complete waterberry, is associated with potassium deficiency.
Sir?
Yes?
In excessively hot regions, can you get any of these symptoms like the dried out edge leaf and this berry just from heat?
No, because, well, sometime or other maybe I ought to dig out some slides showing heat injury. Heat injury is a different type of thing. If it were caused by heat, you'd have half of these berries, half that's exposed to the sun would be burnt, and the other half behind it would be okay. I've got slides to show that because you can get sunburn of fruit, but usually, unless it's extreme sunburn, it'll be a part of a berry, the side that's exposed to the sun. Yeah. Okay, so this type of thing you can get on fruit. Notice the sandy light soil because I'm going to tell you something pretty soon about the incidence. Okay, next slide. Now here is the effect of potash deficiency on the variety Carignan. I was talking to somebody after class last time, and it suddenly dawned on me what I should have known all along, that apparently Carignan, even though it's a high-producing variety and one of the most common varieties over the world, seems to be extremely susceptible to nutritional deficiencies because it's one of our most common for potassium deficiency, one of the most common for boron, and one of the most common for zinc. So potassium, boron, and zinc seem to be Carignan seems to be quite susceptible to those three. But notice the similarity of symptoms. This slide's upside down. It's my fault. But you start over here with the very slight symptoms of this bronzing at the edge, the green center, a little waxiness. Over here, it gets a little bit worse. You get a tiny bit of burning and starting to curl over here. Then you come down to, since it's upside down, which way do I go? I guess over here. Now this bronzing is beginning to burn into what we call necrosis, N-E-C-R-O-S-I-S, which chlorosis, remember that sometimes I forget that people who are not in my field of work don't know these terms, but chlorosis is just a lack of green color. But necrosis is where the tissue dies. So you have those two terms in nutrition work, and now we've gone from chlorosis to necrosis, in which the tissue actually dies. And then you get over to this situation where it begins, I don't know which one, I guess that one should come before here, because you begin to get a little bit of this curling of the edges where it dies. That's not the soil, that's the sidewalk behind it here, Davis. Okay, next slide. Now, one of the oddities about potassium, somebody asked me the other day, how does potassium, how does a vine go out with potassium? Does it go out in 1 year like that, or how does it work? Actually, it works in a sort of an uphill, downhill sort of deal. I told somebody the other day, if they really want to know just exactly how it works, look at the stock market for last week or something. I mean, last week's report for the past 6 months, and it goes up and down, up and down, up and down, up and down, like this. In 1 year, it'll be weak because it happened to overcrop, or had very little crop on it, so on. So that because it was overcropped that year and had a light crop on it that year, the buds form pretty well. And the next year it recovers a little bit, but it's still in a weak condition. So the next year it goes down farther still. See, it had a high crop here, so it weakened it extremely. And then you go into another year in which you have very light crop and very weak growth. But because you have very light crop, the buds are fairly fruitful, so they come back a little bit, and then they continue to go up and downhill like this until you finally get to death. And this is an area, I'm a little ahead of the game here, but these vines are outside the deficiency area, and these vines are in this stage like this, where they had very little growth and very light crop, practically no crop, so that the buds are fairly fruitful, and they'll come back a little bit the following year, but they'll go downhill until finally they die. So let's see the next slide. And this shows a symptom of can you sharpen that a little bit, Margaret? There with the very front, yeah. Okay, now when potassium deficiency was first discovered on tree crops and crops in general, it was in England, and they call it leaf scorch. And you can see why they call it leaf scorch. In this particular area, the shoot growth is very short, very weak growth, and the leaves burn early from the symptoms you just saw, and they drop early, so that you get an early defoliation. That's one of the symptoms of it. It's almost as though you were confusing it with a red spider or leafhopper or something like this that would cause a defoliation. So you get an early defoliation of leaves, which really robs your vine, because I told you this morning you should have that green leaf surface working for a month after harvest. If the leaves turn brown and fall off before you even pick the fruit, it's as though you'd prune them early, so that you get a weakening effect from that, which, as I say, causes the next year's growth to be even further depressed. Now that's a scene at harvest time, or a little after harvest time. The next shot, let's have the next slide, Margaret, shows an area just about 20 or 30 vines away, in which you see the type of growth you should be getting from normal Grenache. These happen to be Grenache vines. So that gives you an idea then of the growth and the symptoms of this. Now if we can have the lights, we'll talk a little bit about the incidents, and then we'll go on with the treatment. Okay, now you've seen something of the symptoms. This leaf edge chlorosis, on minor cases occurring mid-shoot portions, in which now I say it occurs when it's in its mildest incidence. If you have a shoot this long, it may occur on 2 or 3 leaves in the middle here. But if it's extremely severe, this may be the terminal part of your shoot. And in that case, all of it shows the deficiency. All the leaves show it. And you saw the various symptoms of the waxiness and so on this plant. Shawless, once again, working with Concord, has argued that potassium deficiency causes a straggly cluster, a poor set, and a reduced number of clusters. But that's on Concord. In our own work on vinifera, we have not found this to be true. what potassium deficiency does is cause a smaller cluster and a variable maturity, or an uneven ripeness of the cluster, uneven ripening, but no effect on the number of clusters and no effect on set with vinifera. But we want to get around now to the incidence or where it might occur, and the overall statement that we can make to begin with, once again, is that potassium deficiency is most likely to occur on most tree and vine crops wherever you have anything that interferes with the root growth. Anything that interferes with normal root growth is the two first things that you get when you have real interference with root growth. Seems to be potassium unquestionably, and zinc deficiency as a sort of a secondary and perhaps questionable whether or not it's the only one. But you certainly get it with potassium. So that anywhere where you're going to have interference with root growth, you're going to run the possibility of getting potassium deficiency. Well, just for example, under California conditions, overcropping interferes with root growth, because if all the sugars, remember the fruit has the first demand on the sugars being produced, and if you have a terrific overcrop, the fruit requires the sugar and prevents it from going to the roots, which would provide, if it went to the roots, it would provide for greater root exploration, greater root growth. So overcrop is one problem. And oddly enough, both over irrigation or over water supply, waterlogged soil is what you want to put down, waterlogged soil, and extreme drought will cause potassium deficiency. Those two extremes, and I'm saying that because I want to refer to it a moment later. Waterlogged or extra over wet soils as well as dry soils will cause potassium deficiency. Okay, what else will cause potassium deficiency? Those two things, extreme attacks of phylloxera nematodes by affecting healthy roots and reducing normal root growth can, on occasion, cause potassium deficiency. And finally, so far as California is concerned, we get around to a phenomenon which accounts for most of our potassium deficiency, in that Dr. Lillian here 20 years or so ago in pomology did a study on peach tree soils of California, and he studied approximately 100 soils. Put it here, 100 peach tree soils, and he was measuring, in this case, soil analysis, which I've told you I don't believe in, but in this case he wasn't trying to correlate it with tree response. He was just measuring extractable potassium in these soils. And out of 100 soils or so, he found an extremely high and consistent relationship that in the first, second, third, and fourth foot of soil, he found, if we make the size of the letter proportional to the amount involved, he found high K here, lower K here, lower K here, and still lower potassium at the fourth foot level. And at the same time, he found the reverse true with magnesium. He found magnesium low here, a little higher here, a little higher here, and considerably higher at the greater depths. So that we come around now, with that as a background, let me give you one other fact to tie in with this, that one of the most consistent relationships that we find in the tissue or nutrition, tissue analysis or nutrition of grapevine is a very consistent relationship or inverse relationship between potassium and magnesium in the tissue. That if potassium is high, magnesium is invariably low. And the converse. If magnesium is high, potassium is low. And that perhaps is one of the most important points to remember about the nutrition of grapes, is that potassium and magnesium have this extremely harsh or consistent relationship, of inverse relationship between potassium and magnesium. That if K is high, magnesium is low. If potassium is low, magnesium will be high. And that type of relationship. All right, we have this type of soil in our native rolling soils like this of the state, and this may be a height of 2 feet. But you can't irrigate this like that, so you're going to level it. So you're going to go in and level the soil. So you're going to take this high potassium soil and low magnesium soil off the top of here and put it into here, and put it into this hole to level it off. Now you've got the native level under here of high potassium, low magnesium, plus another 2 feet on top of it of high K, low Mg. So now you've got 4 feet of pretty good relationship of high potassium and low magnesium. But what's happened over here where you cut it off? Now you're down perhaps to this level right here, where you have low potassium and pretty high magnesium. So you're in a situation where you've reduced the potassium considerably by this leveling operation, but you've increased the magnesium considerably by the same operation. So that you have not only reduced the available potassium, which hurts you somewhat, but you brought in this antagonistic effect, as we refer to, antagonistic effect, of the increasingly high magnesium. So all I'm building up to is the fact that the most common occurrences of potassium deficiency in California is in areas where they've been scraped or cut in leveling. And you can get potassium deficiency occurring on a high producing variety. I said overcrop will cause it. Something like Thompson or Carignan or Grenache. In areas I've seen it very distinct where you've cut less than 2 feet. Where this little hill you're cutting off is less than 2 feet to fill in over here. So that the most common occurrence in California on an acreage basis in the state from here to Bakersfield is where you have cut a little hillock or a hummock or maybe 2 or 3 acre size and cutting off something like this to fill in over here. If you cut that off and fill in over here, you're going to get potassium deficiency in this area. What are you going to get over here? Where you started out with the natural soil, and then you put 2 feet more of this high K, low Mg on top of it. What are you likely to run into there? You're going to put 4 feet of this type of thing. You should run into magnesium deficiency. Well, I sometimes tell this story and everybody laughs, so everybody get ready to laugh, that where you have this type of cut and fill operation, and you put that type of soil on top of there and then plant vines in it, young vines, they're going to show magnesium deficiency for about 2 or 3 years, perhaps. But by the time the grower notices it, and then reports it to the farm advisor, and he gets a farm advisor out to look at it, and then the farm advisor gets me to look at it, and then I get around to getting down to look at it and get the tissue analysis. Those roots have grown down into this deeper stuff where they got plenty of magnesium and the problem is solved. So that's what I tell people, that there's no point to worry about magnesium deficiency in California because you only have it in some cases for a year or 2 on young vines. In time they grow down into it, time you find out about it and get ready to do anything, it corrects itself.
Well, then as vines get older, you have a higher risk of the potassium deficiency.
Yeah, for several reasons. One is, of course, that I said overcropping is one of the big problems, And one of the things that you enologists know is that the grape juice has a high amount of potassium in it. That's why you get a high precipitation potassium tartrate. So as fruit matures, it pulls quite a high demand for potassium. So that many times you can plant vines on these cut areas and they won't show any deficiency at all while they're young until you start working them to death, putting on a heavy crop, and then they show it. So sometimes, one of the things people sometimes do when they got these areas like this where they've cut it and they planted the vineyard, and then the vines get real sick from potassium deficiency, and they pull them out and they put in a young vine, it grows beautifully. And they say, well, there must have been something wrong with that other vine. But wait till that vine starts to bear a crop, and then it's going to show the same problem. So we have a sort of a double way of looking at incidence then of potassium deficiency. One of things in which we know that it affects the root situation of overcropping, phylloxera, nematodes, high water table, drought, and what have you. And another in which we have this problem of the nature of the soil. And it isn't, I want to emphasize this very strongly, because it's a religion with me almost, is that I don't believe that our situation in California is so much at this level right here, potassium is a deficient level of the soil. It's my feeling that this is a toxicity level of magnesium. With this inverse relationship I'm talking to you about, that this magnesium is so high that it depresses, magnesium being here in potassium, it depresses in the potassium because the magnesium is so very high.
Doesn't magnesium toxicity have some deep rolling also?
Well, the only symptom we know of magnesium toxicity is potassium deficiency. That's all we know for, and I'm claiming that most of what we see as potassium deficiency in California, outside of Napa Valley, and I'm going to mention that right now, but most of what you see down the valley is not potassium deficiency, it's magnesium toxicity in these scraped areas and so on.
How would you alleviate the problem in scraped areas and not scrape it?
No, you have to scrape it to put in the irrigation. He's got a good point, because what I've told a lot of people, if they're going out and buy 160 acres of land, and then you're going to have it level, for crying out loud, make a good map or demand from the leveler a good map on where he leveled. And then watch the areas where you cut the most as your best indicator of deficiency. And then if you get deficiency in those areas, go back and fertilize each of those scraped areas with potassium. But don't fertilize the whole deal, because I'm going to tell you pretty soon they cost quite a bit of money to fertilize for potassium, and you don't want to throw it around like a drunken Indian, spreading money everywhere, you know. You got to put it on where it needs it. Okay, now, to get back to this other idea of potassium deficiency of excess water and drought, we have the best example of this in Napa Valley. Because in the valley floor of Napa Valley, you have excess water until, many times, up until nearly bloom time. I'm going to show you some slides when we get around talking about planting vineyards, in which we dug the holes over in Napa Valley. It shows the tractor going back and forth and cultivating and wiping out the weeds and everything else, and we're out drilling holes to plant vines. We drill the holes 20 inches deep, and the next day we'd come back and each one of them's got about 4 inches of water in it. Plunk, plunk, plunk. You can drop rocks in and hear them plunk. So that you have a situation in much of Napa Valley, even extending up maybe 100-foot elevation on each side of the valley, in which you have extremely high water table up to within 12 inches or so, up until maybe close to bloom time. And this prevents potassium uptake at that time of the year because of excess water. But then what happens in July and August? Now you don't have any water at all, because most of those vineyards are still unirrigated, and the top 12 and 18 inches have dried out pretty thoroughly. And that's where most of your roots are. All those that are below there are drowned out. So you got most of your roots in that top 2 feet. They couldn't pick up potassium because of too much water in the early spring, and can't pick up potassium in July and August because it's too dry. So what do you do in that case? I see some worried looks. I don't know what you do. We put on several potassium trials over there and try to get response. All you can really do is forget the potassium and either try to put in tillage or drain tillage to drain your soils as quickly and as well as possible in the early spring, or maybe spend the money for sprinklers so you can give them a good drink of water, 3 or 4 inches of water in July by irrigation. But our experiments with putting on potassium in Napa Valley have been all negative because of these two contrasting factors which are involved. Now in the San Joaquin Valley you can put on potassium and correct it pretty well. Okay, I'm not sure where we stand on this, but let's look at a few more slides and then I'll talk about treatments in more detail. Now, this is an area up in the near foothill. Move it this way a little bit if you can, Margaret, toward me a little. Yeah. And this is Balico. If any of you know Balico, somebody one time told me back east, if anybody knows where Balico in California is, they know where California is. But Balico is near Merced, up toward the foothills northeast of Merced. And this is just in the edge of the foothills. And these are peach orchards. And this is grapes, and this is Grenache grapes. And here's an area. These are rolling hills. You can't see it here. This is barley land. And here's a place where they cut a little hill off in land leveling and put all the excess dirt over into this hole, which is over here. This is so low they didn't even plant it, but they filled in much of the dirt here. So these 10 or 12 rows of Grenache are beautiful with regard to potassium because they got 4 feet of high potassium soil. But these over in here were deficient. These are my plots. See these green things. I was waiting for somebody to ask what's all those green blobs, but that's my experimental plots where I put on trials of 2, 4, and 8 pounds and so forth. So I plotted this whole thing, graded all the vines, went around and picked out vines and put on fertilizer trials. So those are my experimental potassium plots put out in the middle of this scrape. Otherwise this whole thing would be fairly bald, just like some of these areas in here. And this is, I think at this particular time when this field was taken, this was still in cover crop, but later on it's planted to Thompson's and we still had these deficient areas. And these are peaches cut in the same way, and they show the same type of thing that we get with grapes. And there's a few spots over in here. So that's a type of situation you get with the deficiencies in the central San Joaquin Valley. Next slide, please. Okay, now we get around to treatment. And I guess so you can take notes, let's turn it, well, this is the way it's put on. Let's look at this for a moment, and then I'll turn the lights on so you can take notes. We make a furrow as close to and as deep as we can without cutting too many roots next to the vine, and then put the potassium sulfate right in the bottom of the furrow. And in the coastal counties we do this early and leave the furrows open so we can get as much winter rainfall as we can right on top of this to wash it in. In the valley, in the San Joaquin Valley, we put it in the same type of furrow and then irrigate right on top of it. In fact, often we use that French plow furrow, you know, where they're plowing like this and leaving open a furrow along right under the vines and put the potash in that and then irrigate right down it. We were talking this morning about spring frost, and here's 2 methods of controlling it. These are, of course, the heaters, which we'll discuss next time, and here's a bunch of blocks, which are nothing but king-size charcoal briquettes wrapped up in a plastic bag, which by lighting the bag itself lights the charcoal. And we normally don't leave them right under the vine. They're put under there to get them out of the way so we can do this cultivation. But they would normally be out about at this position to give you some protection from frost. Okay, now let's have the lights and talk about what this is all about. In New York State and in Europe, you can correct potassium in these acid soils with what we refer to as low exchange clays, low exchange capacity clays, and that means nothing except soils that contain clay particles with a lot of clay particles with a very high concentration of these negative charges I was talking to you about last time, when I was talking to you about nitrogen. Some clays you come into that have a lot of these negative particles. Some other clays you work with that only have a very few, like this, for comparison. And where you're working with these low exchange capacity clays, you can put on potassium fertilizers, which of course potassium has a positive valence, so that these clay particles don't attach or tie up very much of potassium, so it can move on down to the root zone. But our Californian, our Chilean, and our Mexican type soils in these arid regions are such that you have a terrific magnetic effect, if you want to call it that, electrochemical effect, to tie on these clay particles. And you put potassium on, and a terrific amount of potassium is tied up. So how do you overcome this? You overcome it, say in New York State, in the East, and in Europe, you can put on 100 pounds of a potassium fertilizer per acre and get a pretty good response. In California, you might as well stay in bed unless you're going to put on a minimum, an absolute minimum of 500 pounds. And that'd be on your very sandiest soils under the very best of conditions in order to get a response to potassium. And those fertilizer plots you saw from the aerial view that I had started at 1,000 pounds and went up to 8 tons, right? Up to 2 tons. 1,000 up to 2 tons per acre of potassium sulfate. So those went from 1 ton to 2 tons of potassium K2SO4 per acre. Or to put it in terms of vines, it went from 2 pounds to 8 pounds per vine of potassium sulfate in order to get the response. And you have to go at something at an absolute minimum, even on the sandiest soils, of 1 pound per vine of potassium sulfate under our California conditions to get a response. The greater amount you put on, like this, the sooner and the bigger the response you get. You can put on 2 pounds on any of them nearly and get a response the next year or maybe 2 years later. But if you really want to get a response in a hurry, you could go up to 8 pounds per vine. But generally, I recommend to people who are really putting on a trial plot to stop at something like 6 pounds. Why 6 pounds? Well, maybe only because a 1 pound coffee can holds 3 pounds of potassium sulfate. And you put a coffee can full on each side of a vine, and that gives you 6 pounds per vine, so it's a pretty easy measure to put on the material. And then put it in those open furrows as you saw, and then you might get the response. That's why I said I want to emphasize that you want to recognize the symptoms, map these areas that you were talking about where you scrape it, and watch those areas, and then if you get deficiencies show up, treat only those areas, because 6 pounds, a ton and a half per acre is pretty expensive, probably $150 per acre at the moment to treat it. So you don't want to treat 40 acres just blindly when maybe only a third of it needs potassium. You want to map these areas and treat the areas that need it. And you want to use potassium sulfate. There's not much potassium chloride or muriate available in California because a lot of these fertilizer people don't want to get sued. Muriate of potash. Most of it is potash or potassium sulfate. When they say potash in California, they mean potassium sulfate. But muriate, which is KCl, you can imagine if you put on 3 or 4 or 5 pounds of potassium chloride, that you might correct the potassium deficiency, but you'd kill the patient with chloride. So I didn't tell this other class because I shouldn't take this much time to tell it, but one grower down at Lodi did do this. He went out and marked all of his, he went out and put on some random treated vines here, there, and yonder with potassium, and he marked them very carefully, each one with a rag, and he went out and put on 3 or 4 pounds of potassium chloride per vine in a trench around each vine. And he told me the next year, he said, you know, I didn't need those rags because the vines are dead, every one of them, so, because he put on so much chloride. So he said, I didn't need the markers. But don't put on potassium chloride in that type of levels. Now, I've talked a little bit to people about putting on a little bit of potassium chloride, particularly in these coastal counties, where you get high rainfall. Because one of the problems with potassium sulfate is it doesn't dissolve very well. It's very, very slowly soluble. And it'll only dissolve something like 10 pounds in 100 gallons of water. Whereas potassium chloride dissolves just exactly like sodium chloride does in your kitchen. It dissolves almost instantly, like sugar. So it'd be nice to use this, and it's probably cheaper. And whereas the potassium sulfate here runs something like 0.050 in terms of this NPK business, potassium chloride, depending on whose brand and so forth you're using, may run 0.060 or 63% or so. So it runs higher in potassium, dissolves much easier, but you got this problem of chloride. Now in the North Coast counties, I'm looking forward to doing some work on this. I think that by using your head and doing a little juggling, you could probably put on 100 or 200 pounds of potassium chloride. Maybe put your nitrate on as potassium nitrate, which I didn't even tell you about the other day, because the nitrate in potassium nitrate is the most expensive of all. But again, it's extremely soluble. Put on your 50 pounds of nitrogen as potassium nitrate. Put on maybe another 100 pounds as potassium chloride. And then only supplement it then with a couple of 100 pounds of potassium sulfate. These are some of the small details that you're not being held for. I'm just talking about you're being held for this other main thing of big high rates in potassium sulfate being applied. So what I'm saying is that if you've got, suppose you've got 40 acres of grapes here, and you only got so much money, and you say, well, I've got enough money to put on, this is 40 acres, and Cook says I need potassium, so I'm going out and put on 250 pounds per acre. So you put on 250 pounds per acre on each of this 40 acres, and say you might as well stay home. But you say, well, I can't afford 500 pounds or 1,000 pounds per acre on this 40 acres. I don't have that much money. Well, instead of putting 250 pounds each year on this, instead of putting 250 pounds on each 10-acre block every year, wipe it out. That doesn't work in California. The thing to do is to put 1,000 pounds per acre per year on the first year here. The next year, this is the first year. The second year, put 1,000 pounds per acre over here. The third year, put 1,000 pounds per here. And I'm running this in the ground, but I want to get the idea across. 1,000 pounds per acre there. And then the fifth year, come back over here and put 1,000 pounds and rotate it that way. That's a way to get a response to potassium in California. Don't dribble it on in little small amounts, because the soil with this terrific, where was my diagram of a clay particle, is such that it'll tie up. You dribble it on in little small amounts, and the clay will tie it up so fast the roots don't get a chance at it. So your next question is going to be, well, what happens? Gee, I put on 1, 2, 3, and 4, and then I don't get back to the fifth year. What's going to happen? Well, let's look at a little bit of further data on this. Now, here's the type of response that you can get by, this is from this business of putting on 2 tons per acre, 8 pounds per vine, and this is Grenache, and this shows you an extremely deficient shoot in which all the leaves on the shoot are showing the deficiency, and this is the type of response you got on an individual shoot basis, which you saw from the air on those green spotches a moment ago. Next slide. Well, something's mixed up. I thought we only had one slide out, but it looked like you got them backwards. Yeah, that's... Okay, this is what I wanted first. Okay. I'm not sure this is it. But anyway, can you sharpen that a little bit? Okay. Now, here's an experiment where I was putting those on where you saw this scene from the air. And in 1956, back over on this side, I had controls. I had 2 pounds of potassium sulfate per vine, 4 pounds, and 8 pounds. This is half a ton, and 2 tons of potassium sulfate applied once, back over here in 56. And here's the yields that we got in 57, the yields in 58, and the yields in 59 from those treatments. Somebody yesterday had a heck of a time trying to understand what I was talking about. These are the amounts of potassium sulfate per pound or pounds per vine applied once only in 56. And these are the successive yields for the following 3 years. And you see the controls went 19, 22, and 30. Somebody always wanted to make a big deal about this. Why did that go up? Well, I gave you a lecture in which I showed yields vary up and down in California quite a bit, and this is just a normal natural variation of the controls. But here is the 2-pound rate. It only doubled the crop here, almost doubled it here, and almost doubled it here for 3 consecutive years after that with 20 cents worth of potash. 20 cents worth of potash gave you 20, 20, 16 gave you about 55 pounds of grapes for 20 cents worth of potash. And if you go to 4 pounds, it increased it a little bit, from 2 to 4, not very much. But when you jumped it from 4 to 8, you really increased the yields phenomenally. For the 3, after 1960, by 1960, these were beginning to taper off. So that would mean then if you applied in 56, 1 year you could wait 1, 2, 3, and put on another application in the 4th year. You follow me? Okay, let's see the next slide. And the next slide then shows you the type of fruit. This is not the best slide I had on this, but let them see this one, Margaret. This is the one that I'm most interested in, this bunch here. Okay, I said that Shawla says with Concords that he gets a reduced set and a reduced number of clusters. I said that we do not reduce the number of clusters, we reduce their size from large down to medium or even smaller. And we delay the maturity. We get this uneven maturity. This is supposed to show you a sort of a reddening instead of a black color that you get on these potassium deficient vines as compared to a more uniform and larger berry, larger cluster set and higher sugar. These are something like 20 or 21% sugar. These are something like 17. But you saw the leaf surface that they had to mature this fruit already turned brown and fallen off. So how do you expect them to build up sugar? So you can get increased crop, terrific increased crop, and terrific increased color and sugar content by applying potassium if you have potassium deficiency symptoms showing. But not unless you do, yes?
Can you overdose it? I mean, like, put too much on?
Well, I put on 2 tons. I mean, what tons we want?
Well,
Yeah.
There's no backer there.
Well, we have not, let's put it this way, we have not obtained any potassium toxicity symptoms under these high doses we've applied here on our experiments. What would be a potassium toxicity symptom? Yeah, you better say that, magnesium deficiency. Okay, next slide. And just to show you that when I said if you have deficiency symptoms showing, because here's where we sampled in Madera County, not too far from where those experiments were carried out, maybe 40 to 50 miles away, 100 vineyards where we took petiole samples over a 10-acre sampling area. We took 100 petioles over a 10-acre sample area, so that this 100 vineyards represents 1,000 acres, more or less randomly selected in the state without regard to weak areas, strong areas, or what have you. And we got samples varying from 9% that were in this range